So maybe sarcopenia and osteopenia. And for those of you who don't know Steve, number one, he's been a very, very prolific scientist. And Steve was really instrumental in kind of consideration and creation of osteoporosis and osteopenia as an indication. And his attention and research efforts have turned much more towards skeletal muscle and the interactions of muscle and bone. So, Steve?
Thank you, Bill, and thanks for the opportunity to be here. So I'm going to take on the story of osteoporosis as a way of trying to tell an advanced story or warnings about the diagnosis of sarcopenia. So I'm going to start with the idea that we define a lot of conditions in medicine using measurements: hypertension, hyperlipidemia, diabetes, osteoporosis, and sarcopenia. And using measurements to define conditions raises three issues in particular that are common to all of these fields. So as you struggle with the definition of sarcopenia, you'll have company. And those of us who've been through that with osteoporosis and those who went before for other conditions. So I'm going to give you an outline, first of the basics of osteoporosis, and then tell you the story about the evolution of osteoporosis and osteopenia, issues and lessons that it has raised, and then put those issues in the context of making the definition of sarcopenia. So here are the basics. Everything you need to know about osteoporosis in about 2 minutes. First of all, bone mineral density is a very accurate measurement of bone, and its measurement is related to risk of fracture. The lower the bone density, as you see at the bottom, the t-scores, minus, plus. It's a continuous relationship. There are no obvious biological thresholds. In addition, bone density declines with age consistently, just as does muscle mass. And the way this is described in the osteoporosis arena that I'll use is by t-scores. T-scores are the distance from a young normal being, about a 30-year-old. So the -1 t-score is about a 10% lower bone density at 30. And here are the issues that I'm going to try to go through one by one, and that is, by definition, cut points for diagnosis when you use measurements are arbitrary, necessarily arbitrary. And in addition, when you choose to compare to young adults, it will generate a high prevalence of whatever diagnosis you make amongst older people. And in addition, ultimately, as you develop drugs for the treatment of the condition, the cut points that you use for diagnosis will inevitably differ from the approach to treatment. And finally, treatments, their issues will arise because treatments may not work by means of the biomarkers that defines the diagnosis, making it hard to consider these surrogate markers or use them in following patients. So let's talk about the first one from the point of view of the history of osteoporosis. Back in the early 1990s, bone densitometers became widely available, and the people who were making the measurements had a problem. What was normal? We were getting numbers that we didn't know. Endocrinologists like to use 2 standard deviations from a mean value to define normal, and so that was done initially. But then a World Health Organization committee met in Geneva in 1992, parallel to a lot of the meetings I hear about now about sarcopenia, where extensive epidemiology was reviewed in relationships between bone density and other endpoints. And it was considered the t-score of -2.0 should be used as the diagnosis of osteoporosis normally. But the prevalence of osteoporosis then went over 50–45% too high. And so someone said, let's make it -3, with the prevalence 5% too low. So this is a too high, too low solution. The Goldilocks knows how to solve by picking a point in between. At a -2.5, things were just right because the prevalence of 15% was fine. score between -1 and -2.5. Why the -1? I've asked and asked and asked, and actually no one can remember. But it has huge implications for its prevalence in the population. So now, when you compare to young adults, as your reference for normal, you end up with a high prevalence amongst the elderly, whatever diagnosis you've got. So in this case, the young mean is about 30, means that with each passing decade, 50, 60, 70, 80, you can see in the dark shaded the proportion of that group, that bell-shaped curve of people who have bone densities, BMDT scores at the bottom. The black line is -2.5, the red line is -1.0. You can see the increasing proportions that begin to fall in those categories. And so the prevalence of osteoporosis rises to 50% by the time you're over 80, and osteopenia is about 50% of people at any given age, and so that means only 9% of women over 80 are normal, and only 20% of those in the previous decade. Well, these definitions have consequences. Many women have now been screened. Over 50% get a diagnosis. You have osteopenia on a red, yellow, and green video. And we've studied this in more than half of patients who get that diagnosis of osteopenia or osteoporosis report anxiety and limit their activity, about 25% limit their activity in order to minimize the risk of falls and fractures. And it increases, of course, even osteopenia substantially increases the chance that we get derived. And my favorite is severe osteopenia, which many patients regard as worse than osteoporosis. The cut points for diagnosis and treatment, however, now will necessarily differ. It would be great if osteoporosis per se were a simple indication. It would be great if sarcopenia became a simple indication for treatment, but there are problems. First of all, when you use any measurement, a single measurement to define risk, there are many other risk factors that come into play. And so that a woman, for example, with one BMDT score, -2.0 at age 60, has a very different risk when she's older, or has another risk factor like smoking. And so when you use just one measurement in order to define treatment thresholds, you're actually treating people who have wildly different risks. So treatment based on bone density criteria, as guidelines had for the last decade or two, T-scores less than -2.5 or 2. In addition, many received drugs for a T-score of a -1 or lower for osteopenia. That meant that millions of young women with low fracture risk, who are relatively young, all they've got is a low T-score, received drug therapy, which will be of little benefit for them even if it works. Older women, on the other hand, have a high fracture risk because of age and other risk factors, may not qualify for treatment because their bone density doesn't cross that threshold. So this creates a problem that has led many to a growing consensus that treatment in the future should be based on absolute risk of fracture. Now you can read into this if you're thinking about muscle, that treatment should eventually be based on absolute risk of the disability or the endpoint, the clinical endpoint of sarcopenia that we care about. And we define these now as treatment thresholds. That's a probability. The treatment threshold is a probability, like a 20% chance of having a fracture in the next 10 years. And if you're above that, treatment is worthwhile. And generally, those treatment thresholds are based on analyses of the cost effectiveness of the treatment. So that we know that above a 20% threshold of risk, treatment is cost effective, and below that level of risk, it's not. So that's the process that the field of osteoporosis has gone through over the last 20, 25 years, and still going through to try to reconcile measurements of bone density and diagnoses with decisions about treatment, and we're moving further and further away, I think, from bone density as the sole basis. Because as you see, new guidelines from the United States have begun to use absolute risk, 20 or 3% for major hip fractures, respectively, as the treatment threshold for women with osteopenia. And the United Kingdom has just instituted muscle therapeutics for sarcopenia, what eventually we go. Okay, but you also can't, I think, do it on the basis of risk alone. It's good to have a measurement, something about bone and muscle in it that indicates some responsiveness to treatment. We don't yet have that worked out well for osteoporosis, but there's one interesting piece. That is that for women whose T-scores at the hip are less than the -2.5 seem to have greater reductions in fracture risk, non-vertebral fracture risk than those who have osteopenia T-scores above that, for most but not all the treatments. And so maybe this acts as a necessary element, something about bone that indicates the responsiveness to treatment when we make our treatment thresholds. Okay, so next issue, and that is that treatment may not work by way of the biomarker that defines diagnosis. And this may have the effect of inhibiting the development of novel drugs. I won't go into the last point unless there are questions, but when that's true, then monitoring becomes problematic. Because you want to monitor the thing that you're testing for, like bone density, but if the change is meaningless, then why monitor? It's misleading. So let's focus on the effects on drug development. Defining osteoporosis by bone density had several effects on drug development. The MDT scores of less than -2.5, that arbitrary, let's draw the line down the chalkboard, became the entry criteria for most phase 3 trials. And FDA-approved drugs for prevention were based on improvement in bone density amongst those with osteopenia in order to prevent crossing the line to osteoporosis. Doesn't make a great deal of sense, but that was the FDA practice for drugs. It's about to become extinct. Thus, drug development is focused on ways to improve bone density, naturally, because that's a regulatory pathway and what's clinically used. But change in bone density turns out to be a relatively poor surrogate marker for the effectiveness of treatment on fracture risk. Now, a word about surrogates. It's important to have validated surrogate markers because if you've got validated surrogate markers, they can not only be targets for drug development, testing new compounds, but the holy of all holies is that with a good validated surrogate marker, you might do trials with just the marker as an endpoint. They can be smaller. They don't have to be large clinical endpoint studies. That's what we keep hoping for in osteoporosis. In order to validate surrogate markers, this is important for all trials that you'll design for clinical endpoints, you have to show that change in the marker in individuals accurately predicts the reduction in risk of fracture. And this is done with the percent treatment explained. We're not going to go into that statistical thing, except that 100% of treatment effects explained means that the change in that marker density accounts for the whole anti-fracture effect. That's a terrific marker. It will be a validated surrogate. It's great, but most of them are in between, and 0% means there is none. The change explains none of the anti-fracture effect. But in order to do this in studies, you must measure something at baseline. You must put serum away. You must make the measurements or the images at baseline, and at least one follow-up time point in every individual in the trial. Unfortunately, bone density is a poor surrogate marker. Its percent of treatment explained is somewhere between 5 and 20%. In other words, the pathway between treatment and improvement in bone density only accounts for 5 to 20% of the effect on anti-fracture effect, and that means that there must be other pathways that account for much of the rest of that percent bone turnover, improvements in structure. Okay, but there's been a barrier to establishing surrogates in our osteoporosis field that companies could remedy, and that is once you've made novel measurements and stored specimens, but generally in small subgroups. And so we've got interesting subgroup findings, but we really don't have sufficient data, and certainly no coordination across the trials to allow us to test and validate surrogates. And so we're now still stuck with large fracture trials as the way of testing new drugs. Okay, so now to sarcopenia. And it's a little bit like going back to the future. The future that I'd like to see avoided is the definition of sarcopenia, or stage 1 sarcopenia, or pre-sarcopenia. I'll tell you that patients won't be able to distinguish between sarcopenia, pre-sarcopenia, stage 1 sarcopenia. They'll all consider it to be diagnosis, and it may create an epidemic of worry in people who are low risk of disability. That's my fear as people start making various definitions. And in addition, risk-based guidelines took us a long time to get there, and they're hampered by the lack of risk data from large cohorts and trials in a standardized way. We don't have coordinated assessments of risk in large cohorts that have fractures and endpoint, let alone disability. And I'm worried that surrogates won't be established because specimens and measurements are only going to be made in trials in small subgroups because it's cheaper in the short term, expensive in the long term when you start to have to continue to pay for large-scale trials. Okay, issues. Cut points for diagnoses of sarcopenia will necessarily be arbitrary, and comparing young adults' muscle measurement as the basis for the diagnosis will lead to a high prevalence of the diagnosis in young people. Okay, so I mean the reason that cut points will be arbitrary in the sarcopenia field is that all muscle measurements either have no relationship at all to subsequent disability, or they have the same continuous graded response with no apparent biological threshold. And in that situation, the definition will have to be defined by consensus of the committee. The committees struggle and struggle and struggle over this, but ultimately, as you saw with osteopenia, there is no point in struggling to the death because there is no right answer. There just has to be final consensus when somebody stands up and says, this is it. And however, in doing so, committees need to carefully consider all the future consequences of the definitions that I was just describing for osteopenia. The fear, the worry, the excess use of drugs, or maybe the underutilization of drug therapy amongst those at high risk who don't meet the measurement criteria. And since all muscle measurements decrease with aging, defining normal compared to young values will increase the prevalence of sarcopenia. Here is a slide with skeletal muscle index versus the young adult values from endpoints 2. You can see class 2, sarcopenia class 1 is -1 to 2 and normal. Clearly, because that index goes down with aging, the prevalence of sarcopenia, regardless of its class, goes up, such that if you were to use this measurement after the age of 60, only a third of the population would remain normal. And then I think it's important in the field to anticipate that treatment guidelines will eventually, regardless of, it will eventually come down to absolute risk in some fashion or another. And ideally then a coordinated international project could collect standardized data about a set of risk factors and clinical endpoints in existing studies or in future studies, some kind of collaborative effort, so that at the end we'll be able to have an international score of risk of some endpoint that's preventable with treatment. Perhaps maybe that endpoint is ADL disability, maybe it's mobility disability, maybe it's falls. But there will be in 10 years, 20 years, a lot of regret if this isn't along the way. And perhaps it could all be developed into a model that I'm taking the liberty to call MAX instead of FRAX for muscle. Okay, and then implications for clinical trials. Make sure that all these risk factors are assessed in all randomized trials in order to allow you to understand what the treatment means for people at various levels of risk of the endpoint. The entry criteria eventually have indications for treatment. So the indications for using alendronate or zoledronate or denosumab typically in osteoporosis drugs reflect what was used as entry criteria for the studies. And so it's led some of us to come to the conclusion that enrollment in trials should not be based on just bone density or a marker or measurement, but should be based on absolute risk of endpoint, regardless of bone density. If that's where treatment's going to go, then that's where trials should start. Now, in addition, trials that are done in this area, I think, need to anticipate that cost effectiveness will be used to set those treatment thresholds under which we may make clinical decisions about using drugs, and that means including in the trials collection of data that are And so the surrogate marker is likely to be a combination measure. And in order to define a good surrogate, both for drug development and eventually as endpoints of trials, I think it's important to collect the measurements of the specimens at baseline and in follow-up in all subjects in trials, in all subjects participating in trials. In order to do this, ideally it would be done across sponsors through something like a collaborative trials group that would help to ensure that we are getting the best bang for our buck in creating surrogate markers for trials. Okay, so defining sarcopenia, I hope will eventually mean that the definition will mean that you've got similar, if you've got that diagnosis, you've got similar risk of the endpoint. Everybody who's got it has similar risk. And condition that responds, it identifies people who respond to treatment. That means there'll be a measure of risk plus some measurement about muscle that indicates its responsiveness. But any diagnosis, any definition that comes about in the next decade about sarcopenia will be imperfect, it will create problems, and it will have to change. So let me summarize that diagnoses based on measurements are necessarily arbitrary. Many areas of medicine and osteoporosis struggle with this. And if you decide to compare to young normals, that means a large proportion of elders will have a diagnosis. Treatments will eventually be based on risk, not diagnoses. And so prepare for that now by getting standardized assessments of risk factors in cohorts and including them in trials and perhaps making those the definition of entry into trials. And markers for diagnosis, like bone density, a simple measure of mass, may be core surrogates in order to establish patterns. And I think that it's important that sponsors of trials collaborate to store specimens and repeat new measurements in everyone participating in a clinical trial. And with that, I'm going to stop and say thank you for letting me come here from San Francisco.
We have time for maybe one question. So where is the microphone first?
If I understand. Mr. Cummings, if I
Yes.
understood you right, the most important point is the choice of the endpoint. Is there a consensus that onset of disability is the most appropriate endpoint?
All those in favor of onset of disability, raise your hand. All those in favor of falls? I mean, I don't think, I'm not in this field, not that I know, but I'm not an expert in the definitions for the endpoints in this field. In osteoporosis, it's even more difficult. You know, fracture is a fracture, but no. In fact, every trial that I know of has defined fractures as differently. Taking 4, taking 6, taking all minus 4. It is a wild madhouse, and so therefore we can't really compare the trials one to another straight on. And so, you know, I think that standardization of the approach to clinical trials is one thing that can be done now, anticipating the needs that the osteoporosis field failed on in the last 20 years.
Thanks, Steve, for completely